All right, so today we're looking at lesson 2.5, which is all about solving inequalities. So we did this a little bit last unit with just regular inequalities, and now we're going to look at it with word problems. So you have a copy of this right in your notes, so I'm going to kind of fill it out here. So if you're, remember, this symbol represents less than, so some key words if you're looking for in word problems might be less than, or maybe is smaller than. If you look here, this is less than or equal to, so that's how you say this one. And you could also say at most, which means you can't have any more, or no more than. So these are like key phrases if you should use this symbol here. This one is represented as greater than, and this one is more than. Okay? And then this one is greater than or equal to, so that's one way to say it. This one you could also say at least, so you can have more, or no less than. So those are all some key phrases if they're wanting you to use these types of inequalities. So I'm going to go through a couple examples. I'm just going to set these up. I'm not going to solve them. So it says use the table above to help you translate the following descriptions. So 4 times a number is increased by 16 is greater than or equal to 44. So 4 times a number, I don't know what this number is, so I'm going to let that equal x. So 4 times a number, so 4x increased by 16 plus 16 is greater than, so this side is greater than or equal to 44. Okay. Number 2 says 6 more than a number is at most 13. So 6 more than a number, I don't know what the number is, I'll use x. So 6 more is x plus 6 is at most 13. So that means I can't have anything greater than 13. I can have anything less than 13, but 13 is the greatest. So this side has to be less than or equal to 13. And if you look, at most is a less than or equal to sign. Those are keyword up there. Okay. The product of a number and 12 is no less than 84. Product means to multiply. A number, I'm not sure what that is, so I'm going to call it x, and 12 is no less than 84. So a number, the product of a number and 12. So if I multiply 12 and x together, I get 12x, is no less. So that means it can't be less than 84. So that means this side has to be greater than or equal to negative 84. Okay. If I flip the page, I just have a couple more examples. So 5 less than 3 times a number is at least 41. So 5 less than 3 times a number, so a number would be x. 5 less than 3 times a number, 5 less, is at least, which means I can have greater than, so greater than or equal to 41. And then finally, 2 consecutive integers have a sum that is no more than 75. So the first thing I'm going to do is make my let statements because, and I feel like a lot of people aren't continuing to do this, but please do. It really does help you when you're, especially if the equation is more complicated. So 2 consecutive integers, that means one right after another. So let x equal my first one, and x plus 1 can equal my second one. And they have a sum that is no more than 75. So x plus 1 is no more than, so it has to be less than or equal to 75. Okay. So that would be how to translate, very similar to what we've already done. Now we're just kind of working with inequalities. Only other thing I want to talk about is possible answers when I have an inequality. So I want to look at something like this. So it says, if the perimeter of a rectangle is between 7.5 and 10.5, what are the possible integers? Integers are any positive or negative number, accounting number. So it can't be decimals. So if it's between 7.5 and 10.5, the numbers between there that are integers are 8, 9, and 10. So the only whole numbers between 7.5 and 10.5 are 8, 9, and 10. So it's kind of, if you get something like this, you kind of got to think about your answer and what the possible answers could be. If it were integers, or say it was rational numbers, you could literally have anything from in between 7.5 and 10.5. So it would be every single number, fractions, decimals, everything in between. But since integers are only positive and negative numbers, there'd be a limited amount of numbers you can have for this type. Okay. So if the width of a rectangle must be less than 8.2, name 3 possible integer values. So if the width of a rectangle, so I'm going to draw my rectangle. So if the width has to be less than 8.2, what possible integer? So integer means whole number. So if it's less than 8.2, I can have 8, I can have 7, I can have 6, I could have 3, I could have 2, I could have 1. However, because we're talking about a rectangle and the width, I can't have a negative width. So I would just keep at positive numbers, but you only have to name 3. So there's a ton of different possibilities. Your job is to name 3. So it's really important you know what integer means and you're able to kind of read the inequalities that way. So go ahead and start the practice.